Hi all. So today we're going to talk about exercise 3.22, circling around the pole. And it is about this mass that we connect via a string and wraps partially around the pole. And we're pulling it with our hand to make sure that this sphere or mass remains in a circular path. And the question is asking us to find velocity as a function of time, and also to find the special value of time and explain why it is special. So first, let's again just draw free body diagrams here. So what forces do we have? Well, we definitely have a tension force here. And that's pretty much it here because it's a top view diagram. We don't really need to worry about gravity since that's already cancelled out by the normal force. So we really only have like one force in this problem. So how can we approach this? Well, since it's a circular motion, it's always smart to just try to decompose it into the tangential direction and the radial direction, to decompose the force into these two directions. Because if we are able to do that, we know then that the radial force needs to satisfy the centripetal force formula, which is mv squared over r, and we can utilize that later. So let's try to do that. So let's just draw straight, connect this to the center. So that is the radial direction. And then the tangential direction should be perpendicular to that radius. So if we draw it here, so we have a right angle here. And then let's call this angle theta. And so now we have the tangential direction and the radial direction. So let's write out the formulas. So the radial direction, we have t cosine theta. It needs to be equal to mv squared over r because it's in a circular motion, and we're using big R because, well, it is circling in a circular path that has radius big R. And then for the radial direction, we have t sine theta equals to something. Well, we don't really know what that something is, so we can just write down ma, which is basically m dv dt. And so these are our two formulas. And so now let's try to solve for v here. We don't want to deal with t here because we don't really know what it is. So what can we do? Well, we can divide this formula by this one. So we have sine theta over cosine theta, which is tangent theta, equals to m dv dt over mv squared over r. And so m cancels out. And let's move the r to the top. So now we have dv dt times r over v squared. And so now this really just becomes a differential equation that we are trying to solve. So let's try solving it. So what if we get all the v's on one side and all the t's on the other side? So let's first move the constants to one side first. So let's do tangent theta over r times dt integral equals to the integral of 1 over v squared dv. And let's try to put in some bounds here. So according to the question, the initial velocity is v0. So we have v0 here and some sort of velocity v. And v0, so v of 0 equals to v0. So then for the time, we're putting bounds 0 to t. And so now we have tangent theta over r. This is just t, or we can write out like t minus 0, equals to, let's try integrating this. So negative v over 1, and we're plugging in v equals to v0, v equals to v. And so now we have tangent theta over r times t equals to negative 1 over v minus negative 1 over v naught. And so this is 1 over v naught minus 1 over v equals to tangent theta over r plus t times t. And so now let's isolate the v term here. So we move the v on to this side. Goes to v0, 1 over v0 minus tangent theta over r times t. And we flip the denominator and the numerator. So we get v equals to this whole thing flipped. So 1 over v naught minus tangent theta r t. And just to be neat, we can also write it like this. To the power of negative 1. So this is a lot neater. So now let's see. So this is a function of t. And basically this is the first part of the question. This is the speed as a function of time. And now what is the special value of time here? So let's observe. So let's look at this expression. So when the denominator becomes 0, it goes to infinity. And that's a special value. So 1v0, 1 over v naught minus tangent theta over r times t equals to 0 is the special value. So what is that? So 1 over v0 equals to tangent theta over r times t equals to r over v0, and then divided by tangent theta. So this is the special value. Essentially, when t approaches this value, the velocity approaches to infinity. And it's just impossible to keep an object from going in a path at infinite velocity. So it just becomes unrealistic.